video, we are going to look at a question on power. Pause the video now and try all parts of this question. Part I asks us to calculate the power developed by Rhea during her climb. Now, this is quite an unusual term, developed, and it does sometimes catch people out, but it basically just means calculate Rhea's power, right? How much power is involved. So don't be thrown off by this word. It doesn't mean anything different. It just means calculate the power. So obviously we need to write down what power equals. It's energy transferred divided by time taken, or energy divided by time. You could just write the simple equation down if it's a calculation. So have we got this information? Well, we haven't actually got energy straight away. We've got the time, that's great, but we've got the weight and we've got the height. So what we need to work out is the energy gained, and we should remember that energy gained is mass times gravitational field strength times height. So energy, GPE, gravitational potential energy, is mgh. And we should realize that weight here equals mass times gravity. So we've actually already got mass times gravity. We've got mg here. So the energy gained is the weight, 300 newtons, times by the height, which is 7. So this equals 300 times 7, which is 2,100 joules. So now we've got an energy, and now we can do the power. So power is energy over time, which is 2,100 over the time 120, which is 17.5 watts. So just two different ways Rhea can increase her power. So how can we increase the power? Well, one way, if we made the time shorter, the bottom of the fraction would go up, would decrease, and that would make the overall value of the fraction increase. So we could say climb the wall, faster. I'm going to make it really clear what I mean, in a shorter time. Or if she could actually make the energy itself go up. So if in the same amount of time she could transfer more energy, so I'm going to say in the same time transfer more energy. How exactly is she going to do that? Well, if I could increase one of these factors here, well, I can't really increase her mass because she's fixed as a person. I can't increase g because that's fixed on this planet, but I can increase the height that she climbs. So in the same time, climb a greater height. Part B, Nicholas climbs 4 meters, does 2,800 joules of work, and has a power of 28 watts. He thinks he's climbed in the shortest time. Show that Nicholas is correct. So we need to do a bit of rearrangement here. So we know that power is energy over time. So we know that power times time is energy. We know that time is energy divided by power. So I'm obviously timesing by time, and then I'm going to be dividing by power both sides. So can we work it out? Well, we've got energy, we've got power. Do we need this? We probably don't need this piece of information because we've been given the energy and the power. So I think we can just do 2,800 divided by 28, and we should see that immediately is 100 seconds. Let's just write it in the table just so we can compare. Clearly, that is the smallest time. So I might just say, to be really clear, 100 seconds is less than 120 seconds, just to show that it's the shortest time. But you might not even need to do that.